Hi everyone, my name is Lydia, and this is what I wish they taught me about econometrics and introduction. So far, we've studied a lot of several situations in which OLS could go wrong. And that would be because of the violations of the different assumptions that we had about the OLS. We've now managed to look through omitted variable bias and reverse causality. We saw the solution to reverse causality, which was using the instrumental variable or the 2SLS procedure to be able to get actual estimations that we could trust. We have seen heteroscedasticity. We've seen when assumption 6 was violated and the variance was changing according to the element. So we had to use robust standard errors, and we show an actual application of that in R. In this little mini arc, we're going to talk about measurement error. This is another common problem, and it's overlooked, but present in almost every real data set. So the question that arises is, what if the variables themselves are measured incorrectly? This is called measurement error, and it turns out the consequences depend critically on where the error occurs. But what do we mean exactly by measurement error? In econometrics, we usually assume our data is accurately collected and it accurately represents the variable we're interested in. In practice, that's often not true. For example, someone could be reporting, let's say, 45,000 pounds as earnings instead of 50,000 because maybe they don't want to disclose the whole amount. A survey could ask how many hours you studied. Let's say someone doesn't want to give the impression that they haven't studied too much, so they instead put what, like we would think, an overestimation of that amount of hours you've studied. Or it could be simply that you don't remember exactly, so that would still mean that you haven't measured it correctly. A country's GDP is revised years after it was first published. Pollution sensors as well, they give imperfect readings. Or self-reported health status doesn't perfectly capture actual health. So it seems that the variable we observe is not exactly the variable we wanted to measure. There is a gap between reality and data, okay? And measurement error is not a niche problem. It is present in virtually every survey data set, administrative record, economic indicator, and learning to recognize and handle it is one of the most practically useful skills in applied econometrics. What you will see most of the times when you have measurement error, you're going to have to think about true value versus observed value. So how do we think about that? Well, imagine you've got the true value, so that will be your X star. And you're going to have an actual observed value, which is actually X, okay? There is a connection between the two of them, okay? The true value and the observed value. Think of the X star as true value that exists in reality. This is what you want to measure. But unfortunately, because we rarely observe this true value directly, instead we observe the X value in here, which contains some error. So the gap between X and X star is actually the measurement error that we're making. We'll formalize this shortly, especially we're going to write X being equal to, so the true value to your X plus some error term, where this is your measurement error. But for now, just hold the picture, true value, and the noisy observation. What are the sources of measurement error? The sources could be human error. People forget, people round numbers, people exaggerate, okay? It could be an instrument error. Thermometers, scales, pollution monitors, GPS devices, they have all imperfect precision. It could be also a data entry error, typing mistakes, coding mistakes, missing decimals. This is very common in large administrative data sets. And the last one is proxy variables. Sometimes we simply cannot observe the variable that we care about. Remember, ability, we use test scores instead. Motivation, we use past behavior instead. Socioeconomic status, we use parental income and parental education instead. So in all of these cases, what we put into regression is not exactly what we intended. Now, proxy variables are a particularly important case and one of the most common in economics, so we'll return to this when we discuss solutions to measurement error. Now, does measurement error always matter? You'll always have to ask the question, if my data contain small errors, does OLS automatically fail? And the answer to this is actually not necessarily. This is one of the surprising aspects of measurement error, actually, because sometimes it causes serious bias, sometimes it doesn't. The consequences depend entirely on where the error occurs, Y or X. This asymmetry is the central theme of the entire measurement arc miniseries. So the same type of error, a random noise, has completely different consequences depending on which variable it affects. The two very different cases that we will see is case 1. We're going to see measurement error in X. And case 2, measurement error in Y. In measurement error in X, we're going to have that X star is the true regressor, which means that instead you observe some X, which is equal to X star plus some error, okay? And the other one is where Y star is true outcome, but you observe Y, which is Y star plus some error, okay? So the two consequences of these two case scenarios are completely different. The distinction between error in Y and error in X is the most important thing to understand, okay? And it's usually quite often tested in exams. So make sure that you pay careful attention once we get to those separate cases in the following videos of this arc. So in the next several videos, what we'll answer is these following questions. What happens when Y is measured incorrectly? What happens when X is measured incorrectly? Why does attenuation bias occur and how large it is? And then how can we fix measurement error? So each question has a different and sometimes surprising answer. And by the end of this mini arc, you'll know not just that measurement error is a problem, but exactly what kind of problem it is and what to do about it. Before we conclude this video, notice as well how this entire measurement error fits into the broader stories. So if you remember, OLS can fail for many different reasons. Omitted variables, a missing variable bias, the coefficient, reverse causality, the direction of causation is unclear. And finally, we've got measurement error. The variable themselves are wrong. So different problems, but each one threatens our ability to estimate causal effects correctly. Now, measurement error in X is actually a form of endogeneity, okay? Because the observed X is correlated with the error term. For exactly the same reason, omitted variable bias creates endogeneity. This means that IV can fix measurement error too, but we'll come back to that when we move on in the arc. Thanks for listening to this video, and I'll see you in the next one.